Hai, Assalamualaikum. Salam satu Malaysia. Salam quarantine. I'm Nuraina Atira from Group 1. So I'm going to explain for forward and backward propagation. So we will start with forward pass. So as the name suggests, we start with the input and then we end with the output. So we have three layers here. So we start from the input. So we want to calculate for the net of the second layer, which is the hidden layer. So this is the node or neuron 4. So we want to calculate the net of neuron 4. We have to calculate the sum of product of the weight sum of product of the input and the weight to the net 4. So W14 x1, the W1 4 multiply with x1 plus with W2 4 times x2 plus with W3 4 times x3. So that is how we get this equation here. And then we to calculate the output for the neuron or node 4, we calculate the f function with the variable of net 4. So we repeat this step for the other node 5, 6, 7, 5, 6, 7, 5, 6, 7. And then we continue from here, we continue to the output layer, which is the net for neuron 8. So this just the same as before. So we multiply the weight of the with the weight for 8 with the output of 4. So plus with the weight of 5, 8 weight output and 5 and so on. And then we lastly to get the output of net 8 we of node 8 we will get the y head. So to calculate that we calculate the function with the variable of the net 8. And then we want to generalize this equation, so we use a notation. So for the notation, we have a three layer, so we use the bracket here as the notation of the layer number. So the input 1 is the first layer, hidden layer is the second layer, output layer is the third layer. So to calculate, so to change the equation, so this net 1 layer 2, so this is node 1 layer 2, node 1 layer 2. So this is how we get the notation. So node 1 layer 2 is equals to W11 of the second layer multiply with the output of the first neuron of the first layer. So output of the first neuron of the first layer. So we plus with the W21 of the second layer, we multiply with the output of the second neuron of the first layer. So that is how we get the notation here. And then for the output of the first neuron, of the second layer, so it's the same. So f is equals to f net 1 node 1 of the second layer. And then we continue for the output of the third layer, so which is the node number 1 of the third layer. So node number 1 third layer is equals to the W11 of the third layer. So we multiply with the output of the second layer of the first node. So and continue and so on. So we continue. So to get the output of the layer here, we get this is the last layer. So we get the y head. The y head is equals to f of the with the variable of the net 1 layer 3 node. So we continue with the backwards pass. The backwards pass, we get by multiplying to find, we want to find the the weight, the updater, sorry, the updater. So to the equation is alpha delta E over delta W for it. Sorry, okay. Delta E over delta for it. So we want to simplify this equation. So we get alpha delta E out times with output 4. So how do we get this? So we take the delta E W for it. We do it by, we obtain it by chain rule. So delta E over y head 1 is equals to delta y1 over delta net 8, is equals to delta net 8 over, not equals to, times with delta net 8 over delta for 8. So we simplify this into delta 8, and we simplify this into output 4. So that is how we get alpha 8 delta 8 o 4. So we repeat this with all the other nodes and or neurons, 4, 5, 6, 7. And then we continue with the hidden layer. So we want to find the updater for the layer. So delta 1 4 is equals to alpha times with delta E over delta 1 4. So we simplify that, it equals to alpha delta 4 times x1. So how do we get this delta E over delta W14? So we obtain that by chain rule like before. So we simplify this chain rule with so we get delta, so delta O4 over delta net 4 is equals to the delta output 4 over delta net 4. We obtain F net 4, and then we delta net 4 and delta W4, we get x1. So we get this from the equation from the forward pass, and then we can get this. And then we get delta E over y1, the error. So we get the error, we simplify that into error 8, and then delta y1 over delta net 8, y1 over delta net 8, we get the function, inverse function for net 8. And then continue for that delta net 8, and output 4. So we get W for it. And then we want to simplify delta E over delta y1 times with delta y1 over delta net 8. So we get delta 8. And then we continue with this simplified equation. We substitute with this equation, so we get this equation. And then we further simplify this. So delta 8 W48, we simplify it to become E4, and then F net 4 E4, we further simplify it to become delta 4. So that is how we get alpha delta 4 x1. So we repeat these steps for the other neurons or nodes. So we will get this equation. So 1 4 2 4 3 4 4 8 5 8 6 8 and 7 8. So just like the forward pass, we want to get a generalized equation. generalized equation. So we get delta of what? Del, delta W11 of the second layer is equals to alpha delta E over delta W11 of the second layer. So is equals to we alpha times with delta 1 of the second layer times with the output node 1 of the first layer. So we do that, repeat the same equation, the same thing for the other nodes and neurons. And then for the output layer, we calculate for delta W11 of the third layer. So the output delta 1 of the third layer. So 1 of the third layer, and then is equals to alpha delta E over delta W11 of the third layer is equals to delta 1 of the third layer times with delta 1 of the third layer times with output 1 of the second layer. Yeah. So we repeat that for 2, 3, and 4. And then we get all this equation. So we want to generalize the equation that we have. So we want to further generalize it. So E8 is the errors. So this we get this by calculating the y head minus the with y. So we generalize it. So E of the first node of the second layer. So is equals to y head or minus y. So if we want to calculate the error of the third layer is equals to y head of minus y. And then for delta 8 is equals to f net 8 times E8. So we change it to the generalized notation. Delta 1 of the third layer is equals to f net 1 of the third layer times with the error of the third layer is equals to delta 1 of the third layer is equals to f net 3 net of the third layer we multiply, or this is the Hadramat notation of the E uh, with the E of the third layer. So same as the hidden layer, E4 is delta 8 W48 is equals to E1 of the E1 of the E of the first node of the second layer is equals to W11 of the second layer and delta 1 of the third layer. So we generalize this. So we get E of the second layer is equals to the weight of the second layer times with the delta of the second layer. And then for the delta of delta 4, we get by F net 4 E4. So equals to delta 1 of the second layer is equals to F1 net 1 of the second layer times with E1 net E first node of the second layer. And then we get this equation. So with the steps, we get y head here. So M is our number of layers. So in our case, we have we have 3. So E of the third layer is equals to y minus y head. And then delta of the third layer is equals to F net 3 times E3. So we continue for backwards. So we continue from the last layer, and then we go up to the last layer is the third layer. So we go up. So we go to the second layer. So EK here. So E2 K is M equals to 1. So in our case is equals to 2. So E2 here is equals to error of the second layer is equals to weight of the second layer times with delta of the third layer. Also with delta 2. is equals to F net del second layer times with E of the second layer. So we repeat this step 2, 3, 4, and 5 here for every data point. So for example, we have 11 training data. So we repeat that for 100 times, and then that after that we finish after we finish that 100 times, we call that is as one epoch. And then after that we repeat steps 2 until 6 for 1000 times uh, according to our weightage. So for example, if we set it as 1000, so we have to repeat it for 1000 times. Thank you.